This one, there you get the slides. I will show it on the next slide as well. So don't be afraid you won't get it. Okay, so my own background is that I studied political science in Berlin, then translation and linguistics and Basque studies in the Basque Country. I did my PhD in computational lexicography, then a postdoc in Hildesheim and Ljubljana. And now I am working for some years already at University of the Basque Country, at the moment at the Department of Linguistics and Basque Studies, and I'm also active in Claria EUS, which is the Basque node of Claria, which is Clarin and Daria at the same time. I'm also active in Wikimedia Basque Country, and I have some contributions to Wikidata, and I'm the maintainer of several Wikibase instances. I will talk about this later. And I've also done some scripting and tooling around these. And actually not a long time ago, is in November, it was in November, that our new working group called DHWiki in the framework of Daria EU has been started to work. And this is a forum where members of different backgrounds come together, namely the GLAM sector, galleries, libraries, archives, and museums, DH researchers, and people active on Wikimedia platforms or in Wikimedia chapters. This is because we are witnessing more and more fruitful collaboration between these three sectors, and now we have a working group that is dedicated to this. So if you find more about, find out more, go to this link. And now about this talk. Here you have the link again, where you can get the slides. I will talk about the FAIR principles. Oh, this piano is nice. I don't know if you hear it online. We hear it quite well. Okay, yeah, I mean, it's not a problem, but yeah. Okay, so the FAIR principles, which are luckily becoming consensus. Yeah, I will talk about them. And then there is the 5-star open data scheme, which is one of the approaches which guarantees completely fair dataset publishing. This is about linked data, right? And then in the main part, I will talk about publishing data on wiki platforms, Wikimedia Commons, Wikisource, Wikidata, and other Wikibase instances. And since this is fair data at its best, as I like to call it, I will talk about more about the Wikidata knowledge graph, which is basically the same thing as on any Wikibase technically. And then we come to some outlook and question and answering. Okay, so the FAIR principles, they are about open science. No, I think everybody of you has at least heard about them. This is about transparency, about describing dataset, describing metadata, about open protocols, open licenses, interoperability, and most important, actionability of datasets by machines and humans. Yeah. So this is a set of criteria, which is luckily becoming standard for publicly funded projects, for example, in EU Horizon calls, which is very good in my opinion, because if something is financed with public money, it should be open and it should be fair in the sense that humans and machines can get the best out of it and not only a screenshot, no? As it used to be in many cases. Now, some of us are active in lexicography. We all know about this. The best lexicographical works are not accessible. Yeah. Okay, so these are the FAIR principles. You have a website about them. And now a bit going into detail, what is FAIR? Yeah, this is an example of bibliographies. The first example is an image. Yeah, this is a very old bibliography, an historical one. Is this content accessible? Well, it is accessible to some point to us that we are humans. We understand that this is an image with some text on it, and then this is bibliographical entries. We can read them and then go to some search engine and search for this bibliographical item. But a machine cannot do this. Yeah, you would have to go through OCR and then structuring and so on. So this is not fair in the fair criteria sense. The second example is a PDF, which at least this, for example, has a good a text layer so that you can copy paste the entries and paste them in some search engine. And also there is some layout that gives you clues, which is the title, which is the author and all this. But still, for a machine without any additional processing, this is not accessible, right? A machine doesn't even know what this is if you don't explain it, yeah? Okay, so what is then a fair bibliography? A fair bibliography is something like this, where you have identifiers, yeah? URI, which is something starting with HTTP, so that it is unique in the whole world, and you can go to that place. We will do this. We go there, and we see that this is a bibliographical item. We see the abstract, and we see the content, and somewhere we will also get the PDF. But the machine sees what is behind, no? So I see the source code behind behind this, and here we see a bit further down here we see machine-readable metadata. Yeah. So here, and it is moreover, they use the Dublin core vocabulary, which is the standard for bibliographical items. So DC title, yeah, the machine would know that DC is the Dublin core vocabulary. This is somewhere above. It must be explained to the machine that DC is the Dublin core vocabulary. Title, and we have source, we have format, we have publisher, we have date, and all the interesting metadata, and also something about the license. There must be some license statement here, which is machine readable. Somewhere here they will talk about license. I don't know exactly where, it doesn't matter, but this is something that the machine wants, no? And here is again the DOI, the identifier of the whole thing. So fair is about identifying things universally. Next example, a public data set. This is about street names in the capital of the Basque, one of the Basque regions, Vitoria-Gasteiz. This is published in some open repository, which is accessible to everybody. Unfortunately, they still have no URI. Yeah, so for accessing this content, you have to go to this URL, which is not the same. This very long thing is a place, it is a command for the server at the Basque government that will show you this entry. It's not the same as a URI, no? As soon as they change the architecture of their server, this URL will not exist anymore. So this is not the idea of universally and nicely identifying things. So here we don't fulfill the fair criteria, but if we go to the entry, we do. Here you have different formats of the same thing. And here you have some metadata, who releases this data set, what is it about, what license, and all this you also get. It is, I go back to my presentation, you also get as machine readable data set here. Yeah, the machine sees this. So here we have the DCAT is the vocabulary used for describing data sets. And here we have everything the machine needs for understanding what is this, who has released this, in what format can I access it, where do I get the PDF, where do I get the other format? And this is the idea behind it, okay? So all this is discussed in a context which is called collections as data, which is more general than what we will talk about here starting in a minute. But I recommend you this, this article of Gustavo Candela and others. Actually, Gustavo is co-chairing the DHWiki working group, and they have this overview of collections as data and what do you have to do for describing the data set you publish in a way that humans and machines find it fair, okay? I also want to talk about this a little bit. This is the 5-star open data scheme proposed by Tim Berners-Lee, the inventor of the World Wide Web. This was 25 years ago. So what does this guy today? He proposes schemes like that, no? So here, this is about publishing data, and it is about the findability and accessibility, interoperability and reusability of the content of your data set. So it is more than publishing something and then describing it. It is about content, and there are these 5 different stars. So for example, you have a bibliography or a dictionary, which will be the examples in this talk, because bibliographies, you all work with bibliographies, and many of you also with dictionaries. So you want to publish your data as a PDF and you describe it fairly. That's nice, okay? You get 1 star. It is better if you publish your data set as table, because then humans and machines get better clues about the content. Yeah, the column header will have something like title or author or publication place or year of publication, so that the machine can interpret better what is what here. You get 2 stars. If you publish your table in a free format where you don't need Microsoft Excel or proprietary software to read it, then you get 3 stars. But if you move towards linked data, which is RDF is the format you need. This is about semantic triples. We will see this later. You get 4 stars. And if you do linked open data in the sense that, that you reuse standard vocabularies, like for example, Dublin Core for bibliographic data, then you get the 5 stars for linked open data according to this scheme. So we may say that 5-star open data is fair at its best. Yeah, it is one strategy to fulfill these criteria. Also regarding to the content. If you have linked open data, the 5 stars, machines can interpret the content of your resource. It is interoperable because you use classes and properties proposed in standard vocabularies. You can link data sets to each other at the micro level. No? For example, you have 2 dictionaries. You have entries in the 2 dictionaries. You can link these together with some relation. No? For example, describes the same lexeme, or the word sense is actually describing the same real-world object or abstract concept, no? Or whatever relation. You can do it because you have URI, you have addresses at micro level of these lexemes, senses, and so on. So this we will see now as put in practice using Wiki-platforms. And if you want to do linked open data, then we are talking about knowledge graphs, right? Because it is about semantic triples. You have subjects, predicates, and objects. For example, here, what you see here on the left is a visual representation of a knowledge graph about Tolkien and the Lord of the Rings and all this, no? So the round things here are the nodes in the graph, and the edges are the properties that connect them. In this representation, since this is done for us, instead of URI, you see here human readable labels, no? If you look at the data, instead of Tolkien, for example, in Wikidata, you have this Q892, which is the address of the URI, no? Which some prefix, this one, Wikidata org entity, that describes Tolkien. So we go here to Wikidata. This is the URI of this entity. Here you have a sheet describing Tolkien, and it is all about semantic triples. No? So the subject will always be this Q892, and then you have some labels, descriptions, and so on, and then you have properties and values. No? And somewhere they talk about place of birth, Bloemfontein. No? This is what we see here. So there's obviously many more data about Tolkien than just this, but this was for explaining that for us, for humans, instead of URI, you see here human readable labels, no? But if I stay there with the mouse a little bit, I see that this is technically, it's Q37701 is Bloemfontein, okay? So here, if you go to this query, this is a database query. Here you ask about all the semantic triples that have Tolkien as subject. The data here you ask subject is this, no? 892. Then you have any property and any object. And here I see this in German because my browser wants German. What is his job? And somewhere here, Geburtsort Bloemfontein, no? Here you have the same thing as in the other, as in this visual presentation of Wikidata, but now you got it from a database query. So this is how these knowledge graph structures work. Yeah, and now to the main part. Fair publishing on Wikimedia platforms. You don't necessarily have your data in a state that you can do linked open data publishing, no? You also want to do publish PDFs, for example. So my first example is you want to publish a PDF containing scanned images. No, this is a historical dictionary. It is no problem to scan and publish this because the author died in the 18th century. Yeah, there's absolutely no copyright on this. So you are able to do this. And I can recommend you that you do it on Wikimedia Commons. Yeah, so you have your PDF containing scanned images, and you send it to Wikimedia Commons. As soon as you do this, you get this URI, which identifies this globally. You can go there as human or as machine and get the PDF. Yeah, these are the different pages. And here actually what we have done is we have put each column of the dictionary as a single page because later we want to do something with this. No? So you see that this PDF is now globally accessible, findable. Yeah, it is globally findable and downloadable. On Wikimedia Commons, you can also, I go there again, you can make structured statements about this, structured data, where you see this, what is depicted here. It is Larramendi's trilingual dictionary. Yeah. So this again is an entity in Wikidata. It is like the one about Tolkien, but now it describes this dictionary. And somewhere here, there must be the link back to the document file on Wikimedia Commons. Yeah. So this is how you make your published PDF absolutely findable, because you can run database queries asking for instances of dictionary, no, instance of multilingual dictionary, which is subclass of dictionary, which have a PDF on Wikimedia Commons. And the tool will give you not only this, but many more. Okay, you have, if you want to publish on Wikimedia Commons, you are forced to provide metadata like who is the author, what is this, what you're uploading, and what's its license. No? And in this case, the license is easy because the author died some centuries ago. Okay, next example. You have your PDF and you want to add a transcription to it. No? You have your facsimile PDF here, which is the same as before, but this is only images. You want to make the content accessible. No? So you need a digital text version of it. You need to transcribe it. You can do this on Wikisource, which is the next platform we mention. And here on this link, you get this. These are the pages of this dictionary transcribed. Yeah, the green ones have been reviewed twice. The yellow ones have been reviewed only once. So you see that we are in the process of transcribing it. I open just any page and I see this. Now here is the transcription of this one. So this is aligned at page level. No? For every page you have a Wikisource page. You can edit this. You go to edit, and this is in Basque now because this is a Basque dictionary. And here you see this text, It's wiki text, no, like always on wiki platforms. For example, this one is italics, no? And then you also have here, we have inserted some templates. This is anchors so that we can link to these places from the outside. So this is about accessibility, no? I will show you in a minute what this is good for. Link anchors, yeah. Okay, and also on Wikisource, there are some metadata describing this document. Okay, so now I said this is about accessibility and what we are doing with link anchors. Again, on Wikidata, we also have lexical entries. We will talk about this a bit later. This is a lexical entry describing a Basque noun, inchaur, which is the nut, okay, walnut. This lexeme, this Basque lexeme, is described in this entry of this Spanish Basque Latin 18th century dictionary, actually in two entries. One is the walnut tree and the other one is the walnut, the fruit. Okay, nuez, nogal and nuez. It's this dictionary is Spanish Basque, no? So now I click on it and I get exactly to the place where this is in the dictionary because I had inserted these anchors, yeah? So this is a strategy how to make your PDF content accessible. In this case, it makes a lot of sense because a dictionary, there you will have the anchors on entry level, no? You could also have anchors on sense level if you want, but in this historical dictionary, case of this historical dictionary, this is maybe enough, no? Okay. So you can add your anchors to Wikidata to the right place, no? To the lexeme you want to describe. We have decided to add it to the Basque lexeme. We could also add it to the Spanish lexeme, of course, if we want. Okay, next example. You want to upgrade your tabular data as linked open data, no? Remember the scheme by Berners-Lee. Tables are worth less than RDF data, no? So you want to increase the amount of stars for your dictionary CSV file. This is an example. This is also a real example from, this is a Quechua dictionary, which we have been collaborating to transforming it into linked open data using Wikibase, which is the same thing as Wikidata, but for yourself. No, I will explain this later. So here you see the columns, lemma, category, Spanish, English, German translation equivalents. And here you see how this has been transformed into an entry on Wikidata, which is the same content, but in this semantic triple format. Okay, so here you have senses and you have here these descriptors in different languages describing that Quechua sense, which has its own identifier. You can link to it. If you have your data uploaded to a Wikibase, it's not only findable because you have URI on entry level, on sense level, and on forms level. I come later to this. You can also get this data through an API or through these database queries. I showed one example before, and it is absolutely interoperable because the standard behind this is Ontolex, which is the recommended standard for lexical data in RDF. Okay, so back to the big picture of the wiki platforms. All of them are based on the same thing, which is the mediaWiki software, which is very popular. It is a free software. Everybody can install this. And it is said that 60,000 instances are running worldwide. I cannot know this for sure, but colleagues comment this. And all the others are built on top of it. Okay, so Wikibase, for example, is an extension of mediaWiki, and the same is true for the others. All the ones that you see here on the right, are run by the Wikimedia Foundation or one of its chapters. but you also can have your own instances and run them on your own. You can have your own mediaWiki, which is like something like an empty Wikipedia for you, so to say, no? And you can have Wikibase, which is an empty Wikidata for you and your content, if so to say. And Wikibase Cloud, this is a hosting service provided by Wikimedia Germany, where you can set up in 5 minutes, you can set up your own Wikibase instance so that you can have your own Wikidata, yeah, and fill it with your own content. And moreover, you can federate it with the big Wikidata, but about this a bit later. Okay, so here you see that my point today is that the 5-star open data really nicely put into practice using Wikidata or your own Wikibase. And also there are some pages describing the integration of the other wiki platforms, which are not Wikidata, on Wikidata. No? I showed you how a transcription project on Wikisource, no, this I didn't show, but it's also true. If you go to the entry describing our Basque dictionary, there you have the link that sends you to Wikisource, or you have the link that sends you to the original PDF on Wikimedia Commons. And this kind of integration is also true for the other platforms. For example, if you go to Saramago on Wikidata, you see here the usual statements, Portuguese, writes in Portuguese, is a writer, born, and so on. But you have here the links to 109 Wikipedia articles describing this person in 109 different languages. And you have also Wikiquote, which is another platform, quotes in 23 languages of this person. And you have on Wikisource, you have 2 entries about this author. And it can be that somebody has started to describe some text. This we could find out now going there, but at least there are pages describing this author on Wikisource, and you get this information on Wikidata. So it is something like the central pillar, no? Connecting all the platforms. So here are some query examples that demonstrate this. I said before, you can ask which dictionaries are being transcribed on Wikisource. Yeah, so this is the query for it. And here in this result, you will hear somewhere here in this 177, there will be our Basque dictionary. You see that this dictionary, for example, it is transcribed on different places. Yeah. No, this is not the same. This is Malayalam English. This is English Malayalam. So this is different. But on different Wikisource platforms, there are projects concerning the same source dictionary. And yeah, so if in this result, you can be sure that this is really dictionaries that are being transcribed, no? Because Wikidata gives you this information. You can also ask for birthplaces of lexicographers. Why not? So here, I make it a little bit bigger so that you see what we are doing here. We are asking for items that are that have a job, yeah, that do something which is related to, which is a subclass to lexicographer. No, so they are lexicographers. They are working as lexicographers or as something which is a subclass of lexicographer. Then they are born somewhere and they have Wikipedia articles about them. And so this is actually a condition. I only want lexicographers with articles about them. And then their birthplace has GPS coordinates, and I want to see this as map. No? So let's see what happens. This maybe it's a slightly more complicated, so it might take a while, but it should deliver soon a result. Let's wait a bit, or in the meantime, start with another one. Articles about dictionaries, languages of dictionaries described in Wikidata. Okay, this we will also start to run. Is the map in the meantime there? Yes. So these are the lexicographers that are as famous as to have Wikipedia articles about them. Okay. And this is where they are born. Yeah, so I can zoom in. Oh, that was a bit fast. Portugal, Portuguese lexicographers, born in Lisbon. I have here 4 of them. So I go to this node and I see here a person, Solomon de Oliveira, worked as lexicographer according to Wikidata and was born here, okay? So this is something you can do. And if we go back to the query and take out the Wikipedia criterion, then it should be more than 1,807. But in the meantime, we go to the other one and see that these are the languages of dictionaries that have Wikisource transcription projects. Yeah. Here you see this. In general, in this kind of queries, also languages that are, even minority languages may appear because there is no restriction. No, these wiki platforms are accessible to anybody with no cost, not more than a computer and the internet connection, and you can start. No, so if you want to go into detail, and you see there is one transcription project in this language, Walloon, no? Belgium and France. Okay. So I hope you got the point that the best thing you can do is doing linked open data. Yeah. And yeah, and Wikidata is there. We will talk a bit more about Wikidata and also about Wikibase, which is the same thing, but for your own content without mixing it up with the main Wikidata. Here's a very good article about Wikidata, which I recommend to you. And yeah, how is this organized? So it is interesting that on Wikidata and on any other Wikibase, you have the ontological layer and the lexical layer. Okay, so to begin with, you have entities. These are the URIs. For example, Saramago, we have already seen with this Q number. No, so the namespace prefix, this part from HTTP to entity is always the same. And then there comes this Q identifier, which describes this writer. What is said about Saramago: instance of human, award received, Nobel Prize in Literature, notable work, Gospel according to Jesus Christ. All these are again entities which are described. No, human is part of humanity. This Nobel Prize is instance of literary award, which is again another Q identity. And no, you understand how this works. So this is about relations of entities between entities, and every entity has its own Q number. So of course, and this is actually we said this already, but as a recapitulation, since Saramago is a writer and writes in Portuguese, we can ask for anybody else who fulfills the same criteria. Who is writer, and writes in Portuguese. And then I also want to see the birthplace of the people and the GPS data. No, it's a bit slow today. No, it's here. So I have in Wikidata 5,177 people writing in Portuguese, where they actually have the statement that they work as a writer. Yeah. And now these are the GPS coordinates, and I want to see this as map. So I change to map and see the map. No, and you see, as expected, no, that Portuguese-speaking countries have more dots here than other countries. No, so these are the writers in Portuguese that are on Wikidata. You have here Azores, Cabo Verde, and so on. Yeah. And and the same thing is true for bibliographical items. No, bibliographical items, for example, this one. This is instance of scholarly article, and its subject is fair data. Okay, and you have a Wikipedia article about this entity, which is the same as this. So if you go here, you see the sheet again. You see that this is a scientific article. It has author, it has main subject, and everything is expressed in these semantic triples. And yeah, and that's the thing. So any entity, it can be a real world object, it can be a person, a place, an article, a building, anything else, or abstract concept is an entity here, which starts with a Q and has its relations. Okay, and then you have the linguistic side, which is entities starting with L. So this describes lexemes. Yeah. The underlying data model is Ontolex. It is visualized like this. This is the model, how it is visualized in the Ontolex documentation, which you find here. It is about lexical entries, and linked to the lexical entry is word senses and word forms, which are the inflected forms. And then from the sense, you have a link called Ontolex reference to the ontology entity. And this is here the most interesting point, in my opinion, that, for example, here in the L3549, which is the English noun foot, you have three senses. One is the unit of length, the second one is furniture part, and the third one is anatomical structure found in vertebrates. And each of them is linked on Wikidata. This is called item for the sense. In Ontolex, it's called Ontolex reference to the correspondent ontological entity. Okay, so we see this on Wikidata, how this looks. We see this here. This is here. Usually in lexemes, you have these identifiers which lead you to other dictionaries, Merriam-Webster and so on for English, Oxford, and then you have these senses. So the first one has this item, which is here. It is unit of length, instance of unit of length, part of imperial system of units, some Wikipedia articles about it, and so on. So we are again in the ontological world now, but we had started from the word sense, and you can do the same thing with the three senses. If you click here, you get to autonomy, subclass of anatomical entity, and so this is here you have again Wikipedia articles describing this. Okay, so this is how this works. This is how the lexical and the ontological side link. Here is a graphical representation of a German lexical entry with lemma Pferd, which is horse in English. You have, it's the same thing, but visualized in this way, in this graphy way. This is the Ontolex lexical entry. Then you have different senses. One is describing the horse, the animal. This is the item describing the horse, and this is the item for the sense link that connects the lexical world here and the ontological world. And the same thing is true for the second sense, which is the chess piece, which is also called horse in German, but knight in English. Okay, so the greens are ontological world. So also the language German is here part of the ontological world. So you might ask, for example, which lexemes describe domesticated mammals? Because you have here, this horse is subclass of domesticated mammal, and we have a lexeme, the sense of which is linked to it. So there might be more, not only this German word sense that links to horse, but more like this, So you can query for this. You can ask here, I have subclasses of domesticated animal, and I have lexemes with a sense that link with Objekt für diesen Sinn in German, in English, item for the sense, to this item. So I run this query, and today it's a bit slow. I don't know if there are many users now on Wikidata. No, it's there. So I have 1036 lexemes describing with a sense describing domesticated animals on Wikidata. No? So now I could restrict this. And since the language is also part of the ontological world, I can say, okay, I want this, but only for West Germanic languages, for example, no? Or only for Romance languages. So instead of any language, I would allow here only subclasses of Romance languages. Yeah. So it has really no borders. You can ask here, do complicated queries. Yeah, and then a third entity type on Wikidata starts with P. Yeah, we had Q, we had L, now we have P, and this is the properties. So this is the edges on in this graph. Every property has one data type. So when you create a property, you have to decide what kind of property, what data type it has. No, it can point to another item, for example. It can be an external identifier, which is what we have, for example, for lexemes and the link to Oxford Dictionary, whatever. And you have some more data types here. So a date of birth property, for example, which on Wikidata is this, has data type point in time. No, and you even have these GPS coordinates as data type, no, geographic coordinates. Okay. So as a then it is important to mention that some properties come preset on any Wikibase. It's the stuff which is black on the page, okay? So for example, here you have Q409, Bob Marley. Bob Marley has labels, alternative labels, and description, yeah? Here it is the label, the preferred label. Then there are alternative labels, also known as, and then there is description here in the middle. These are represented in the RDF representation using standard vocabularies, so RDFS and SCOS and schema, which are, W3C recommended standard vocabularies. And then any other property you create, like for example here, this is the blue stuff on the page, yeah? So this starts with P, and it lives only in your Wikibase, or it lives only in Wikidata, unless you express that it is equivalent to something else. For example, I can have on my own Wikibase the birth date property, and I say, okay, this property on Wikidata is that other, and so I can then connect them or send my own birth dates to Wikidata or vice versa. So this is how this works. The blue stuff can be changed, the black stuff cannot be changed. And for lexemes, it's also the same thing. The ontolex part of the model cannot be changed. So here, as a small recap for how ontological and lexical level relate to each other, this is a human, an instance of human playing the guitar, and its label is Bob Marley, and this entity is member of Bob Marley and the Wailers, okay? So I also have here a lexical form. No, I have a lexeme, which is guitar in English, and one sense of this guitar is linked to this ontological entity, which is the instrument Bob Marley is playing. So if I combine the two, I can have a lexical form. In this case here in the corner, you see guitars. It's a plural form of a lexeme, which has a sense which is linked to the ontological item describing the entity subclass of musical instrument which Bob Marley plays. Yeah, so this works with all languages, of course, as soon as they have content on Wikidata. Yeah, then there is Ordia. Ordia is a tool to explore the lexicographical data on Wikidata. Yeah, I have prepared something here. Ordia. Here, for example, Ordia tells you which are the properties most used on Wikidata lexemes, and the most used is grammatical gender. Yeah, and then here already the third one is this German dictionary external identifier. You see, they have aligned their own dictionary portal entries in 200,000 and 6,000 cases with lexemes, German lexemes on Wikidata. And then for forms, you have pronunciation, hyphenation. This is what people most use, yeah? And for senses, you have item for the sense, which is what we have seen, but you also can have translation, synonym, and so on, yeah? You can also go here further down and see what else are people using, describing lexemes, senses, and forms. Here on Ordia, you can also go to this language thing, and you see what statistics about languages. No, so at the moment, the language that is best described in terms of has most lexical entries is German with more than 200,000. Then Russian, Danish, Estonian, and here in Malayalam is seventh one, and you see this. You can go further down. Yeah, so you see at what point is the description of lexemes on Wikidata in this moment, and then you have some more statistics. Okay, you can explore this by yourself. And also in Ordia, you have this tool. Yeah, why not? We can go there for a second and say that we want to have here a Spanish text, Spanish Espanol, and say my example was, I don't want to invent something else now. Hendrix destroyed guitars. Okay, so this is a very short sentence, and it will tell you that destrozaba might be singular past imperfect first person or singular past imperfect third person of destrozar, no? Because this appears in the data. It doesn't know, it is context agnostic, no? So it cannot decide which one of the two it can be, but according to the word form data in Wikidata, it can be one of the two, no? And guitarras must be the plural of guitarra because there's no other form with no other annotation than that. Hendrix is not described as a lexeme, okay? Good, so this is nice to play around with. And yeah, then you can do federated queries. This is interesting. We go back to the bibliographical world. You can ask, of course, you can ask about works of Garcia Lorca and about Garcia Lorca at Wikidata. Now here you say, okay, what am I saying here? That Lorca has an ID on this other service, which is Cervantes Virtual, which is one of the big bibliographic data servers in Spain. So I'm asking, I'm here at Wikidata, no? But I'm asking, okay, Cervantes Virtual, what do you have of Lorca and about Lorca? And they sent it to here, no? Because this is linked open data, it is connected. It functions with the same standards and with this Sparkle query language and all this. So what I am getting here is actually content from the Cervantes Virtual. No, I have here works about Lorca, and I can do this with any other person which has this BVMC ID. If I go to Lorca's page, I see that this here is Lorca. That there is somewhere this ID, no? Here, BVMC person ID, it works through this, okay? And depending on whether these other servers accept my Sparkle Federation query, it can work the same way, no? On the linguistic side, we also have examples for this with Lila, but now we don't have time to go into detail with that, but it works as well. So last point is that, as I said, you can have your own Wikibase in 5 minutes using Wikibase Cloud. The idea is that you federate it with the main Wikidata in something called the Wikibase ecosystem, so that you don't need to have all the data on your own Wikibase. No, for example, you are listing authors of scientific papers, what we are doing here in one project. In Neoli Wikibase Cloud, which is quite recent, we have here authors, no, on this Wikibase instance, but we are not collecting their ORCID or their VIAF or their birth date or whatever. We are getting this from Wikidata, no? And if look, this is me. In my case, the data was on Wikidata, but in this other case, for example, here, we have no birth date. So if we manage to get this birth date of this person, we will put it on Wikidata and not on our own Wikibase instance, because then everybody else has it as well, no? So this is how you can get the best out of federation. And now, since we are actually running out of time, very shortly, why should I have my own Wikibase then? Why shouldn't I do everything directly on Wikidata? Some use cases require that you have your own data model, no? And you want to create your own data model ad hoc, including properties. You cannot create new properties on Wikidata unless you go through a process and reach consensus about this new property in the community. On your own Wikibase, you can do it in half a minute. Yeah, here is the documentation of the data model, which is the same for every Wikibase, also for Wikidata. Then, for example, in a research project, you might have the requirement that you want to have your own research group working on the data and nobody else. This can be a requirement. So this might be a reason for your own Wikibase. Then your data might be too noisy. Think about OCR dictionaries or something, no? You won't send this directly to Wikidata and expect that the community will correct it. You will do it first on your own instance, and then as soon as you reach a quality level that you find appropriate, then send it to Wikidata. Can be another motivation, no? Or you have data which is too specialized or too fine-grained for Wikidata, some dialectal, historical stuff or whatever. Then, of course, on any Wikibase instances, you can have text pages, yeah, like on Wikipedia, describing your project. This might be another motivation for having your own instance. And then the experience tells us that in some cases, people find it easier to engage in meta discussions about the project if it is an own instance, because the meta discussion on Wikidata is in English, and you immediately engage with a large community. So, for example, in this Quechua project, we decided to have our own Wikibase instance because the Quechua speakers would then have their own forum, their own platform to discuss their issues in Quechua without feeling exposed or disturbed by the whole world, which is talking English and is doing this for 20 years and is not just starting, okay? So this might be another motivation. And then this, we are really running out of time. How do you upload your data to Wikibase? Here you have to learn something about JSON representations, but there are also tools that allow you to fill out forms. For example, this should open a form for creating a new artist entry on Wikidata. So here there will come now in a second the properties that an artist should have. Yeah, so artists usually have this kind of external IDs. They have languages, they have parents, they have birthplaces and all this. No, so if you fill out this form, you don't have to search for the appropriate properties because this form gives it to you. And there are some more interesting tools that make your life easier. Okay, so now I have some more slides presenting Wikibase projects, but this you will have to explore by yourself. And if you have any questions, then write to me. This last one is about the corpus data. Okay, so we are starting to represent corpus contents on a Wikibase so that every corpus token gets its ontological entity and can be linked then to a lexical entry or to another entity describing place, person, or whatever. Okay, and this is this data model. There's also a paper about this. You find this, and until here, I would like to thank you. And in the remaining time, if you have any questions, please go ahead.